Now we have the volume of solids of revolution. So we have here three methods that we can use and involving or getting the volume of the solids revolve around a axis. So it and that will be either x or y axis. So we have the first one, which is the this method. So your dA, or the differential area, must be perpendicular to the axis of revolution. So we already have the formula there, as you can see. So we have V is equal to pi integral of r squared dh. And then cylindrical shell method, dA must be parallel to the axis of evolution, while the washer's method, dA is perpendicular to the axis of revolution with clearance. So the volume will be integral of r2 squared minus r1 squared dh. Okay, so without further ado, let's get into the next to an example. So for this example, we have okay, so we have find the volume of solid generated by revolving the area bounded by y equal to um, x cube, y equal to 8, and x equal to 0 about the y-axis. So the axis of revolution will be about the y-axis. So the axis of revolution will be here. Okay, so that's the axis of revolution. And then I already drew the graph of the following equations. So we have y equal to x cube. So the y equal to x cube will be this one. So this is y equal to x cube, and then this will be your y equal to 8. And of course, the y-axis will be your x equal to 0. Okay. So the area bounded by that will be this area. Okay. So this area. Okay. As you can see, since the axis of revolution is at y-axis, we can use the first method, which is the this method. So for the this method, the dA must be perpendicular. So if perpendicular, so is if the axis of revolution is the y-axis, so your rectangular strip will be this one. Okay. So this will be your rectangular strip. Okay. There you go. So what will happen here is, since that is a rectangle, so of course this will be your x, and then this will be your dy. And then using the formula under this method, you'll have here v is equal to the pi, okay, integral of r squared dh, where your dh here will be your dh here will be your dy, okay, and then your r will be your x, or the radius of the disk um that will be produced if you revolve that area. Okay, so you'll have your v is equal to pi integral of your r squared is x, or x squared, and then your dh will be dy. Okay, but of course we must have a limits here with respect to y. So as you can see, the lowest point of y is at the origin, which is 0. Okay, here, and then the highest point is at here. So that is 0 to 8. Therefore, the limits must be 0 to 8. Okay, and then um we have to find x squared, and then we already have the y is equal to x cubed, right? If I will take the one third of take or raise both sides by one third, you'll have here y is equal to one third equal to x, and then squaring both sides, you'll have y equal to two 2 thirds equal to x squared. Therefore, we already have the value for x squared, which is v pi integral of x squared now will be y raised to 2 thirds dy from 0 to 8. And then if you will get the integral of this one, you can use a simple power rule formula, or you can just use your calcu. What you will get here is um, 96 over 5 pi. And then this will be your answer. Okay, so that is how you use this method. Let's get into the next problem. So we have our next problem, which is a sphere with the radius of 3 meters is bored along its diameter with radius of 2 centimeters. So find the volume of the material left in the sphere. So I already drew the circle. So we have the x and y coordinates or x and y axis. And then you'll have here the circle. So for the circle, it says here that 3 meter, the circle is 3 meters is radius and then bored along its diameter with a radius of 2 meters. Okay. So you'll have here, so you'll have something like, maybe something like this. There you go. Okay. And of course, the other side too. So that's what it will look like. And then, so this is the part that we need to get there. Yeah. So as you can see, since it is bored along its diameter, therefore that will be also the axis of revolution. So the axis of revolution will be here. So in this case, we can use the cylindrical shell method. So for the cylindrical shell method, we'll have v is equal to 2 pi integral of RL dx. What variable did we use here? dr, right? Okay, dr. So we have, so this will be your dA. Okay, okay. So as you can see, from here to here, this will be your y. So that is y. So of course, the lower part is also y. Therefore, we can say that this is 2y. Okay, and this will act as your length, and of course, the radius will be this one. Okay, which is just x. Okay, and of course, this will be your dx, and then this will the one that will act as your dr, and then your x will be your r. So let's do this. V is equal to 2 pi integral of r. Your r is x, right? And then your length will be 2y, and then your dr will be dx. Okay, but we must have a limit. So as you can see, from from here, this is 2, right? And then of course this is 1. Therefore, although the radius is 3, therefore what we need is only this part. Okay, so that is from 2 to 3. So this is 2 to 3. So those are the limits. And then remember that this circle, since that is a circle and then the radius is 3, therefore the general equation for that is we can get the standard equation of a circle, which is x squared plus y squared equal to 3 squared. Okay? But we need to find the value of, we need to replace y here because we have here a dx. Therefore, y here is just equal to the square root of 3 squared, which is 9 minus x squared. And then we can replace now the y here. Okay, so v is equal to 2 pi, okay, integral of 2 to 3. And then we have the x times 2, and then the y will be a square root of 9 minus x squared, okay, dx. And then all you have to do is you can just use your calculator to evaluate this one. After you evaluate that using your calculator, the answer will be 46.83 cubic centimeter. And then this will be your final answer. Okay, so we have for number 3, find the volume of the solid generated by revolving the area bounded by y squared equal to 4x and then x squared equal to 4y. So about the x-axis. So let's try first to draw this y squared and 4x and x squared equal to 4y. So you can see those are both parabolas. So we have y squared equal to 4x, which is opening right, and then x squared equal to 4y opening upward. So this will be the first parabola, and then we have the second parabola, which looks something like this. Okay, so something like that. So those are the two parabolas. Um, denote. So this is opening upward. Therefore, this is x squared equal to 4y, and then this one will be y squared equal to 4, right? And then we are asked to find the area here. So this area. But since as you can see, and then the revolve, it is revolve at the x-axis. So here is the revolution. So as you can see, there will be a clearance here. Okay, so this part. So in this case, we'll be using the third one, which is the washer method. So that you can also only use this if there's a clearance or the area bounded is not touching the axis of revolution. So for the washer's method, dA is perpendicular, should be perpendicular to the axis of revolution, but with clearance. Okay? So the dA must be perpendicular. So if that is the axis of revolution x, therefore our is this one. Okay? So so this should be this is dx, and then for the radius of that, you'll have two radius, which is the R2 and R1. Okay, so let's get the volume. So the volume for this one is pi, okay, integral of, okay, R2 squared minus R1 squared dx. So this is simply since that is dx, okay, so that is in dx. Therefore, your volume here must be, we can rewrite this as um y squared to equal, no, not r, y1 squared dx. And then in this case, if you will change the y's, the y2 and y1, all you have to do is to get the y2, the values of y2 and y1, and then all you be left here will be all in terms of x. Okay? And then this is just simply upper minus lower. So the upper one will be this one, right? So this is the upper one. So this will be your um y2. Oh, no, no, that's not the upper one. The upper one will be, okay. So this is the upper one, right? So the upper one will be this one, which is this one. So this is your y2, and then of course this will be your y1. So we already have the y2 squared, which is 4x, and then for this one, we can rewrite this as y1 is equal to x squared over 4. Okay? And then let's try now to uh, substitute the values. Okay? So v is equal to pi, okay, integral of y2. What is y2? Y2 is 4x. Okay? So that is already squared. So this is 4x minus, and then y1 is x squared over 4, I think. Yeah, but this should be squared. Okay? So this should be squared, and then dx. But we still have the limits. Okay? So for the limits, we have here two equations which are x squared equal to 4y, and then y squared equal to 4x. All you have to do is just equate those two, and then you can get the intersection. If you get the intersection, you'll get 0, 0, and then 4. Okay? Therefore, the lower limit will be 0. Okay? So we're looking at x, or 0, and then the highest limit or the higher limit will be upper limit, which is 4. Okay? So therefore, here will be 0, 2. Okay? So that's basically it. So if you will now use your calculator, you'll have here 96 over 5. Right? Okay? So this will be your